The year is 1934. We are deep in the heart of the Soviet Union. The country is in the middle of a frantic, brutal transformation. Joseph Stalin is in power, and he has a singular obsession: gigantomania. Everything in the Soviet Empire had to be the biggest in the world. The biggest factories, the biggest dams, the biggest armies. It was a matter of national pride. It was proof that communism was superior to Western capitalism, and naturally, this obsession extended to the railroads. The Soviet engineers were summoned to the Kremlin and given an impossible order. They were told to build a steam locomotive that would make the American trains look like toys. They were told to build a machine capable of hauling 3,000 tons of coal all by itself, without a helper engine. The pressure was immense. In Stalin's Russia, failure was not just a career setback, it was a crime. If you failed to deliver, you could be accused of sabotage. You could be sent to the Gulag in Siberia, or worse. So, the engineers at the Voroshilovgrad locomotive factory went to the drawing board. They didn't just want to push the limits of engineering, they wanted to shatter them. They designed a monster. A machine so large, so heavy, and so rigid that it defied the basic laws of geometry. They called it the AA-20. It was named after Andrey Andreyev, a powerful Soviet politician and Stalin's close ally. Naming a train after a leader was a dangerous gamble. If the train succeeded, you were a hero. If the train failed, you had insulted the party. The AA-20 would go down in history, but not as a hero. It became known as the machine that destroyed everything it touched. This is the story of the only 414-4 locomotive ever built, the story of the track eater. To understand why this train was a catastrophe, we have to look at the anatomy of a steam locomotive. In the 1930s, the United States was also building massive trains, like the famous Big Boy or the Challenger. But the Americans used a clever trick called articulation. Imagine a long bus that bends in the middle to turn a corner. That is an articulated train. The wheels are split into two groups, and the front group can swing left or right. This allows a giant machine to snake through curves smoothly. But the Soviet engineers were stubborn. They believed that articulation was complicated and prone to breaking. They wanted something simpler. They wanted a rigid frame. So they did something that had never been done before and has never been done since. They put 7 driving axles in a row. That is 14 massive steel wheels, all roughly 5 feet tall, locked together in a single solid steel line. When you add the pilot wheels at the front and the bogie wheels at the back, you get a configuration known as a 414-4. When the AA-20 rolled out of the factory on January 1st, 1935, it was a breathtaking sight. It was nearly 100 feet long. It weighed almost 300 tons. Its boiler was huge, looking like a factory smokestack laid on its side. It was the largest rigid-frame locomotive in history. The workers cheered. The propaganda posters were printed. It was the perfect symbol of Soviet power, big, heavy, and unbending. But there is a reason why nobody builds rigid trains that long. Physics. A railroad track is not a straight line. It is a series of curves, switches, and junctions. When a train enters a curve, the wheels need to pivot, but the AA-20 could not pivot. It was a steel beam. Imagine trying to push a long, straight ladder through a curved pipe. It gets stuck. When the AA-20 hit its first curve, the forces involved were violent. The front wheels slammed into the outer rail with the crushing weight of 300 tons. The metal screamed. The locomotive didn't go around the curve. It tried to straighten the curve out. The force was so great that it ripped the iron spikes right out of the wooden railway ties. It spread the rails apart. The tracks groaned, bent, and snapped under the pressure. Behind the locomotive, the rails were left twisted and broken, as if a giant hand had crushed them. It was literally eating the track. The engineers panicked. They knew they had a disaster on their hands. They tried to fix it with clever tricks. They made the center driving wheels blind. This means they removed the flanges, the lip on the wheel that keeps it on the track. They turned the center wheels into smooth rollers, hoping they would slide sideways on the rails during a turn. They also installed special devices to allow the axles to float side to side by an inch or two. But it wasn't enough. Operating the AA-20 was a nightmare for the crew. The suspension was stiff. The engine was prone to hunting, a terrifying phenomenon where the locomotive wobbles violently from side to side at high speeds. Imagine sitting in a vibrating steel box, knowing that 300 tons of metal is trying to jump off the rails at any moment. And then there was the problem of the switches. Railroads rely on switches, points where the tracks split. These are delicate mechanisms. When the AA-20 rolled over a switch, its wheelbase was so long that it bridged the gap between the rails in a way that wasn't supposed to happen. It crushed the switch points. It derailed constantly. Every time the AA-20 moved, a maintenance crew had to follow it, repairing the destruction it left behind. It was like driving a tank down a highway. Yes, it can move, but it destroys the road for everyone else. And there was another, almost comical problem: the roundhouse. Steam trains need to be turned around. They drive onto a turntable, a rotating bridge in the train yard. But the AA-20 was too big. It didn't fit on any turntable in the Soviet Union. It was longer than the bridges. This meant the locomotive could only go forward. If it reached the end of the line, it was stuck. It had to be decoupled and painstakingly moved backward or driven on a giant loop, which wasted hours of time. For a year, the Soviets tried to make it work. They ran test trips between Moscow and Leningrad. The AA-20 proved it had power. On a perfectly straight track, it was a beast. It could pull heavy coal trains effortlessly. But the Soviet railway network was not perfectly straight. It was old. The rails were often light and poorly maintained. The AA-20 was a machine built for a railway system that didn't exist. By late 1935, the reports were piling up on the desks of the Ministry of Transport. Derailment in the Shcherbinka yard. 3 miles of track destroyed near Moscow. Switchgear crushed. The political climate was changing. The failure of such a high-profile project was dangerous, but the reality was undeniable. The AA-20 was a failure. Quietly, without any fanfare, the pride of the Soviet Union was parked. It was shunted onto a siding at the Shcherbinka test facility. The fire in its belly was put out. The water was drained. The massive wheels stopped turning. It was never used in regular service again. For 25 years, this 300-ton giant sat rusting in the yard. It became a ghost. Rain and snow ate away at the AA-20 paint on the cab. It stood as a silent monument to engineering arrogance, a reminder that you cannot cheat the laws of physics, no matter how much political power you have. In the 1960s, the order finally came. The locomotive was quietly cut up for scrap metal. It was a tragedy. If it had been preserved, it would be the most impressive museum piece in the world today. But the Soviets didn't want to preserve their mistakes. They erased them. Nothing remains of the AA-20 today. No wheels, no whistle, no nameplate. Only a few grainy black and white photographs prove that it ever existed. The story of the AA-20 is a lesson in the difference between big and smart. The Americans solved the problem of size with flexibility, the articulated big boy. The Soviets tried to solve it with brute force, the rigid AA-20. Flexibility won, brute force lost. The big boys hauled freight for 20 years and are legends of the rails. The AA-20 hauled nothing but shame and was melted down into razor blades. But we still remember it, because there is something fascinating about a machine that was too strong for its own good. A machine that was so powerful it destroyed the very ground it walked on. So the next time you see a train winding gracefully through a curve, remember the AA-20. Remember the screeching metal and the flying spikes. And be thankful for the engineers who learned that sometimes you have to bend so you don't break. Thanks for watching Iron Legacy. If you enjoyed this story of the Soviet track crusher, hit the subscribe button. And let me know in the comments, do you think modern engineering still suffers from gigantomania, or have we learned our lesson? See you in the next one.